Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Convert 1-butyne, HCCCH to CH3, to 1-D-butanol, which is a butanol, CH2 is equal to O end, where the aldehyde hydrogen is replaced by deuterium, i.e. DC, is equal to O, CH2, CH2, CH3. Moving on to the next step. Sodium amide, NaNH2, then D2O. This is a base that deprotonates the terminal alkyne to form an acetylide anion, which is then quenched with D2O to place a deuterium on the terminal carbon of the alkyne, giving DCCCH to CH3, 1D, 1-butyne. Diacetylborane then H2O to NaOH. This is hydroboration oxidation using a bulky borane, which performs SY in addition to a terminal alkyne giving an aldehyde via anti-Markovnikov addition. The boron adds to the terminal carbon. With a normal terminal alkyne HCCr, hydroboration oxidation gives an aldehyde RCH2CHO. Moving on to the next step. First treat 1-butyne with NaNH2 then D2O to give DCCCH to CH3. Then perform hydroboration oxidation with diacetylborane then H2O to NaOH. The boron adds to the terminal carbon, the D-bearing carbon, giving after oxidation, the terminal carbon becomes the aldehyde carbon. The aldehyde formed would be DC is equal to O, CH2, CH2, CH3, which is 1-D-butanol. This seems to work. And for the final step. However, the correct answer is C. 3. The transformation cannot be carried out. The reason, when diacetylborane adds to DCCCH to CH3, the regioselectivity places boron at the less substituted terminal carbon, but the terminal carbon already bears a deuterium. After SYN addition and oxidation, the vinyl borane intermediate gives a vinyl alcohol, enol, which tautomerizes to the aldehyde. The issue is that during the tautomerization step, the deuterium on the carbon alpha to boron is lost because enol tautomerization exchanges that proton deuterium with solvent. Therefore, the deuterium label is not retained in the final aldehyde product. Alternatively, examining step I then to more carefully, the hydroboration of DCCr places B on the terminal carbon, C1 bearing D. After oxidation, C1 becomes C is equal to O, aldehyde, and the D that was on C1 is lost in the process of forming the carbonyl. The CH-D bond at C1 is broken when C is equal to O forms. Therefore, the deuterium cannot be incorporated into the aldehyde position using these reagents. Neither sequence I then to nor to then I will successfully place D specifically at the aldehyde position and retain it. The transformation cannot be carried out with the indicated reagents. Option A. I then to fails because the deuterium placed on the terminal alkyne carbon is lost when that carbon is oxidized to the aldehyde carbonyl. Option B. To then I. Hydroboration oxidation of 1-butyne first gives butanol, no D, then NaNH to D2O cannot place D on the aldehyde carbon. Option D. To alone gives butanol with no deuterium. Therefore, the correct answer is C. Therefore, the correct answer is option C.